Okay, so let's have a look at this stats question. So this is from the 2019 paper, question 2. Okay, right. The following question was asked as part of a survey. How do you usually travel to work? Circle one of the following. So the question is, do you walk or cycle, bus or train, car or other? Okay, and part A said, put a tick in the correct box below to show what type of data this question would give. Tick one box only. Your four choices are numerical continuous, numerical discrete, categorical nominal, categorical ordinal. Okay, so what is the difference between them? Well, numerical is numbers. Okay, so they are both numbers. So if the answer to your question is a number, such as maybe what age are you, then that is numerical data. Okay, if the answer to your question is words, then we call that categorical data. So the answer to our question will be words, so therefore it is categorical data. Okay, so to explain then just continuous and discrete while we're at it, continuous data is any value. Okay, so if I asked you what height were you? Okay, what weight are you? Okay, you could be any value at all, okay, including fractions of values and 0.01s and 0.1s and so on and so forth. Discrete data then is which only has certain values, okay, so it has certain step sizes. So shoe size, for example, is discrete data. In other words, you can be size 5, you can be size 6, size 7, you can even be 7.5, 8, but you can't be size 7.6, 7.7, 7.8. So your shoe sizes goes up in step sizes. So for example, you could be size 7, size 7.5, size 8, and so on and so forth. But you can't be anywhere in between. Whereas if you think about weight, you could indeed be 7 stone. You could also be 7.1. You could be 7.01, 7.011 stone. Okay, so that's the difference between continuous and discrete. Okay, then for categorical data, what is the difference between nominal and ordinal? Okay, so ordinal data has order. That's how I remember it. Okay, now what does that mean? Well, it means it has a pecking order. So one thing is better than the other. So for example, grades in an exam. Okay, so if somebody says, what did you get in an exam? You could say A, B, C, D, and E, for example, or H0, H1, H2, H3, H4, H5, they have an order, okay? A is better than B. B is better than C. Okay, another one would be if you were asked a question, how much do you like vanilla ice cream? Okay, you could say love it, like it, neutral, dislike it, hate it. Okay, they have order. So that's categorical ordinal data. Okay, now on the other hand, nominal data has no order. Okay, in other words, one answer isn't better than the rest. So a question I use as an example for this is color of your hair. Okay, so whether you have brown hair, grey hair, blonde hair, black hair, one color isn't better than the other. Okay, so therefore that is categorical nominal data. It has no order. So I remember ordinal as having order and nominal then is the other one. So therefore, what type of data is this? Well, it's definitely categorical because it's words. It doesn't have an order, like one way of going to school is not better than the other. So therefore, it is categorical nominal data. The table below gives information about the ways men and women in Ireland travelled to work in 2006 and 2016. Write down the modal way of travelling for both men and women in 2016. Okay, so mode is the value that occurs most often. Okay, so that's what the mode is. The modal way then is just the way of describing it. So what was the most often or the most common way of traveling for both men and women in 2016? Well, we look at the 2016 data, we can see by far the most people, because this is percentages and you know it, 100 is the most people travelled by car in 2016. Okay, so the modal way of transport was car. Part C, complete the table by filling in the 3 missing percentages. Okay, so we have to fill in this value, and of course this value. Okay, so this is all of the men and how they travel to work in 2006. So it all must sum to 100. Percentages always do. So I'm on my calculator and I'm adding 12.1 plus 8 plus 62.6 plus 15.3. In other words, I'm adding all of these and I'm going to subtract my answer from 100. So plus 8 plus 62.6 plus 15.3. And I've got 98% for that. And 100 take away 98% leaves me with 2%. So 2% not stated. Okay, let's do the same for percentage women. So 15.4 on my calculator plus 11.3 plus 71.4 plus 1.2. And for that one, I am getting 99.3. So 100 minus 99.3 is 0.7. Okay, and then percentages here, percentage of women. Well, I know they all have to add up to 100. Okay, all percentage has to add up to 100. So you can add them up if you wish, or you can just know that they add up to 100. Evie says in 2006, women were more likely to walk or cycle to work than men in 2006. Okay, is she right? It's 2006. Well, yes, she is right, because I can see 15.4% of women walked or cycled to work versus 12.1% for men. So show that Evie is correct. So I would say 15.4% of women walked or cycled compared to 12.1% of men. Okay, so she is right. So Alison then says in part E, more women must have travelled to work by car in 2016 than in 2006, because 71% travelled by car in 2016, but only 71% did in 2006. Is Alison correct? Okay. This is quite a confusing one, okay? Because 71.9 is indeed bigger than 71.4. However, the problem here is you're dealing with percentages. Okay, so when you get percentages of a number, we don't know how many people were surveyed. We don't know that that is 71.4% of what number. We don't know that that's 71.9% of what number. So therefore, we cannot say, therefore, that the number of people is bigger. We know the percentage is bigger, but we don't know if the number of people is bigger. Okay, so she's not correct. Okay, and the reason is it's in percentages. Okay, 71.9% of a smaller number could be, all right, could be less than 71.4% of a bigger number. Okay, and just to explain that to you, Okay, I'm going to say let's get 25% and 50%. Which one is bigger? For example, I'm just picking these numbers because they're easier. Well, you would say the 50%. I would say, is there more people here than here? Well, maybe not. If I get 50% of 100, then that's 50 people. Okay, it's half them. If I get 25% of 1,000 people, then that's a quarter of them. So it's 250 people. Okay, so although the percentage here is bigger, it's got less people. Okay, because it all comes down to the percentage of what. Okay, and you can always, if you wish, you could always go e.g., for example, and put something like that in there. So if you can't think of how to answer it in English, you can always answer it with a maths example if you wish. Right, F. In total, in 2016, roughly 990,000 men and 880,000 women travelled to work. Using the figures in the table, work out the total percentage of people who travelled to work by bus or train in 2016. 2016, bus or train. Okay, bus or train, 2016. Okay, so I just brought that up there so we could see it. So in total in 2016, so we're over on this side of the table, roughly 990,000 men, which is this one, and 180,000 women travel to work. So work out the total percentage of people who travel to work by bus or train. Okay, so let's find out how many people are these. These are the percentages. Let's find out how much. Okay, so it's 8.3% of 990,000. Okay, and any word you see that word of, it means multiply. Okay. So on your calculator, you can go 8.3% using the percent sign of 990,000, or you can go 990,000 divided by 100 and multiply by 8.3. So however you get percentages, that is how you do it, okay? So just to explain what I mean by there, you can go 990,000 divided by 100 and multiply by the percentage you want, or you can go 8.3% on your calculator and do it that way, or you can convert the 8.3 to a decimal and do it that way. Okay, each of them should give you 82,170. Okay, so that's the men. Let's have a look at the women. So it's 10.5% of 10.5% of 880,000. Okay, so 880,000 divided by 100 multiplied by 10.5, and I'm getting 92,400 for that. Okay, so the total then is 174,570. Okay, so what is it saying? Work out the total percentage of people. So that's the total number of people who travelled to work. Okay, so how many people travelled to work? Well, I need to figure that out. Let me do it over here. Okay, so total number travelling to work is 990,000 plus 880,000, and that is 000, 8, 16, 17, 1870, 000. So then to get a percentage, you put what you have over the total and you multiply it by 100 to change it to a percentage. Okay, let me put that into the calculator. Four, 570 over 1870000 and multiply that by 100 to convert to a percentage. And I'm getting 9.33529. 9.33529, we'll call it that one. Okay, and then it says rounding 3 significant figures. Okay, so significant figures, not decimal places. So that's a significant figure. That's my second significant figure. That's my third significant figure. So I always have to look at the fourth one. Okay, so if I have to round this to significant figures, it is 9.34%. Okay, if it was 3 decimal places, it would be 9.335. But that counts as a significant figure. Okay, so it's 9.34%. Okay. Part G, complete the table below showing the angle in a pie chart for each of the ways men travel to work in 2016. Show your work. Give the angle correct to the nearest degree. Okay, I'm going to insert a new page in here now. And I am just going to take this question with me just to give us a bit more room so we're not sticking it in the corner. Okay, so this is how to draw a pie chart. Okay, so complete the table below showing the angle in a pie chart for each of the ways men travel to work in 2016. Okay, so if you think about any circle, okay, any circle has 360 degrees in it. Okay, that's a full circle. So what you're saying in a pie chart is you have to break this 360 degrees up in proportion to whatever percentage is here. Okay, so how do you do that? Well, you do it one by one. So you look at the people who walks or cycles. Okay, how much have they? Well, they have 12.2% out of the 100%, and I'm going to multiply that by 360 degrees. So what is their share of the percentage out of the 100? And we give them the same share of the pie. Okay, so 12.2 over 100 multiplied by 360. So I am getting for them 43.92 degrees, okay? Or for all intents and purposes, 44 degrees, okay? Because that's going to be too hard to draw. So when we're drawing it, we'll end up drawing 44 degrees. Okay, let's look at the next one. Oh yeah, I have to write it in here. So the nearest degree, 44 degrees. Okay, so the next one, bus or train. Okay, what proportion, what percentage have they? 8.3. Out of the 100, where am I getting the 100? Because it's per cent, and that's per cent being 100. So it's out of the 100, and we'll give them the same proportion of the pie. Okay, so 8.3 over 100 multiply by 360 again. So I am getting 29.88 degrees for that one, or 29.30 degrees. Okay, car is next. So 60 out of 100. So this is going to be by far the biggest section of the pie because that number 60 is a good bit bigger than the rest of them. So 60 over 100 multiplied by 360, and I'm getting 216 degrees for that one. So a huge one for that. Other, so it's 14.2 of the 100 multiplied by 360 degrees. So let me go back. 14.2. So I am getting for this one 51.12 degrees, or to the nearest 51 degrees. Okay, and then not stated is 5.3 out of the 100 multiplied by 360 degrees. Let me go back and change that to 5.3 in my calculator. And I am getting 19.08 degrees for that one, or to the nearest 19 degrees. Okay, and they are the angles then. Yeah, I'm not surprised to see the next bit is complete the pie chart. Okay, So I'm going to do this for you digitally, so it won't be as accurate as if I could draw it for you in person. Okay, so what you need is the protractor, so that's the semicircle bit with all the angles on it. Okay, we always start drawing from here. Okay, so tradition has it, and it doesn't really matter, but tradition has it that this is where you start drawing your angles from. Okay, so that's my starting line. So what I'm doing is I'm putting my protractor down here. Okay, so this line that comes down here at 90 degrees is going to be right on this dot here. Okay, so right on that dot that I'm coloring in red has to be where that 90-degree line down the center crosses with the line that's going to cross on your protractor. Okay, and I'm doing some constructions with you at the minute, and one of the constructions is to construct an angle. Okay, and I'm doing it with a different camera, a visualizer, and you'll be able to see me measuring angles. Okay, because that camera is shining down on my hands and I'm using pen and paper. Okay, so that goes down here. What's my first angle I have to measure? 44 degrees. Okay, so down goes my protractor, and you're going to come from this side. Okay, so you're going to start where it's 0 degrees on this side. Okay, all the way up to 44 degrees. Okay, let me just mark that in. So 44 degrees, I'm getting to be somewhere here. Okay, so then I draw a line between the center point like that. Okay, so what you do then is you put in your angle, 44 degrees. And if you have room, if it makes sense, you can put in walk or cycle. Okay, see how you are for room. Okay, now I know you can't imagine it, but I'm turning my page around, and my new start line is this one. So instead of starting here, now I'm starting here. So the cross of my protractor is going here. So the 90-degree line will be here, and this is the flat line at the bottom. So 30 degrees is my next angle. So again, the bottom of my protractor is on that red line now. Let me change it to a different color. Let's go purple for the next one. And I need a 30-degree mark, okay? And my protractor keeps slipping on this screen of the iPad. Anyway, you'll get the gist. So there's my 30 line up here. Can you see it up here? Okay. So again, draw a line between the center and where I put in that 30 degrees. Okay, so that's 30 degrees, that angle, and that is bus or train. Okay, and again, I've now turned my page around, and this now is my new starting line. Okay, so my page is turned around so that that's at the bottom. Now, the next angle is hard enough to go in. It's 216. So it's gone past the 180. Okay, so again, I'm putting down my protractor so that that crosshair is on that purple line. Okay, and you see I'm marking a place over here. You see it down here? That's my 180 degrees. Okay, so let me just show you what I would do. So I'm kind of drawing in just a temporary line there, and I'm turning around, and on my calculator, I'm going 216 degrees minus 180 degrees. In other words, I'm working out how many more degrees do I need. 216 minus 180. So I need 36 degrees more, okay? So what I've marked on my screen now is 180 degrees, okay? So now I need to go another 36 degrees beyond this and then rub out this line here. Okay, so that's just a temporary one because I need to put my protractor now down on this line here and measure my 36 degrees, okay? So let me rub out this line. I no longer need him. So I'm putting down my protractor on that purple line here, and I'm measuring another 36 degrees. And it is my pen. It is somewhere up here. Okay, so let me change color. Let's go orange this time. Oh, sorry. Doesn't like me messing around. Okay. Okay, let me get my rubber and just rub out this little line that I temporarily had there. Okay, and this is your angle, 216 degrees, and it's car. Okay, and then you turn your page around so that this is now your starting line. And the next angle you have to draw in is 51 degrees. Okay, and what's that? Other. Okay, so down goes my protractor on that orange line. Let me change color. Let's go green. So 50 degrees this time is here. Okay, so 50 degrees, and this is other. Okay, so pie charts take a small bit of time to do. And my last angle then is 19 degrees and it's not stated. So what I do is I put my protractor down here and hope that this is 19 degrees, okay? Because that's all that should be left. If it's not, you're just out by a little bit on some of your angles here, okay? So you can go back and check them if you wish. I am a small bit out. I'd say if I was to guess, I'm about 17 degrees rather than 19 degrees, okay? Which is what I'd expect because my page is slipping, okay? So that's 19 degrees and it's not stated. Okay, so that is your pie chart. Label each sector, that's what we've done with the car, the other, the not stated, the walk, cycle, the bus or train, and the size of each angle clearly. Okay, so I hope that's okay. That's your pie chart. Okay, and the question just keeps on going. Okay, so this is the last part of it, which is part H. The diagram below shows the main ways the primary school students travelled to work from 1986 to 2016. So I can see the dark black line is car, the grey line is walk or cycle, and the dotted line is bus or train. Okay, write a paragraph to describe the information above about the ways the primary school students travelled over the period from 1986 to 2016. In your answer, you should use information in each of the 3 lines in the diagram. Okay, so let's describe what happens from 1986 to 216, and it wants us to do each one. So let's take each line as it comes. So let's do the grey one for no reason at all. Walk or cycle. Okay, so let's write. So let's say something from 1986 to 2016, the number of primary school students, so I always try and use as much of their words as I can, primary school students decreased. Okay, and then I'm going to have a look at the axes and see how much did they decrease by. So they were 50%, and that's what, about 25% decreased. They went from 50% to 25%, okay? And of course, you could have said they halved, okay? Or something like that. So that is the percentage of students. I never even said which ones they were. What was the grey one? And the number of primary school students. So what I should have had in here was walking or cycling. Decreased. They went from 50% to 25%. Okay, bus or train, the number of students travelling by bus or train also dropped from about 20% to about 10%. That squiggly line is just maths language for about. Okay, and then finally, let's have a look at car. The majority of students are now coming to school by car. Okay, it went from 25% in 1986 up to 60% in 26, which is a huge increase. Something like that. Anything that describes the curves and what they're doing. Okay, you can talk about this one out. This one's kind of flattens out, that the number of people who walk or cycle is kind of flattened out. The same here. This is kind of got a gradual increase and then it kind of flattens out a little bit. Okay, and that was that long question.